Hello everyone, welcome to the lesson on basic combinatorics. It's all about counting. We're going to start off with the fundamental counting principle, then move on to permutations, and then combinations. Let's start off with a definition. The fundamental counting principle says, the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. Let's apply that to our first example. This morning, Sea-Dog woke up and couldn't decide what to wear. He had to decide between 2 pants, 3 shirts, and 2 shoes. Help Sea-Dog find all of his outfit possibilities. Well, according to the fundamental counting principle, we can say that the number of pants he has times the number of shirts he has times the number of shoes he has will determine how many different outfit possibilities he has, which is 12. And that is true. And it's pretty nice to look at a tree diagram to see the number of possibilities. First, he has 2 pants to choose from, then 3 shirts. So at this point, we have a total of 6 outfits. And then 2 pairs of shoes, then gives him 12 different possibilities here. And you can use that tree diagram with any fundamental counting principle problem. This next example would not be a good one to draw a diagram of. There would just be too many different branches. Let's look at this one. It says that you are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices, with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you choose the answer? Can you answer the questions? So I have 10 different dashes representing the different questions, and in each different question, we have 4 different answer choices. So the first question, we have 4 different answer choices. Second question, we have 4 different answer choices. Third question, 4 different answer choices. And so if we want to figure out how many different total options we have of picking the answers on this test, we would have to multiply. And if we multiply, we have a 4 to the 10th power, which gives us 1,048,556 different ways that we can choose the answers on this test. Let's look at our next problem here. Counting principle example number 3. Telephone numbers in the United States begin with 3-digit area codes followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with 0 or 1. How many different telephone numbers are possible? Okay, so we have 10 total different digits that we could choose from. And in the first spot for the area code, we can't use a 0 or a 1, which means that we're left with 8 different options there. And then the second spot for the area code, we have all 10 digits, and then the third spot as well. So if you multiply 8 times 10 times 10, you're going to get 800 different area codes that we could choose from in the United States. The telephone number cannot start off with a 0 or 1. So once again, we have an 8 there, and we have 10 different options for all the other digits within the telephone number. So we want to multiply to figure out how many total options we have for all of the telephone numbers in the United States. And we have a lot. We have over 6 billion different ways of getting a telephone number here in the States. Okay, so we're going to move on to permutation right now. And a permutation are different arrangements of a group of items where order matters. The ordering matters in the group of items. So let's think about a race where we have first place, second place, and third place. And let's say that there's 5 people in the race. And in the first position here, how many different ways can we get first place? Well, we got 5 people in the race. And then we go to the second spot. How many how many ways can we get second place? You got a total of 4 people that could get second place because we already chose first. Now for third place, we have only 3 people that could get the third place position. So we have a total of 60 different ways that we could get first, second, and third place out of a total of 5 people there. So let's address the order mattering part a second. So let's say Mr. R, he gets first place, Miss S gets second place, and Mr. K gets third place. Well, that's different. That's different. The order is different than if, Mr. K gets first, and then Miss S gets second, and Mr. R gets third. So permutation, the order matters. The way that you arrange things actually matters. Let's look at this first example here. It says that you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can those offices be filled? We have 3 different positions that need to be filled, and we have 20 different people that could fill those positions. In our first spot, we're picking the CEO, and we have 20 different people. But as soon as we pick that CEO, for the operating manager, we only have 19 people to choose from. And then the last one here, we have treasurer. We've already picked 2, so we have only 18 to choose from. So if we want to figure out the different possibilities we have, we would have to multiply. And we end up with 6,840 different ways we could choose those 3 offices with 20 different people. Let's look at the next one. We have a corporation that has 7 members on its board of directors. In how many ways can it elect a president, vice president, secretary, and treasurer? Similar to the last problem. So picking the president, 7 people have a shot. Once the president's been picked, we have 1 less person. Once the VP's been picked, we have 1 less person. Once the secretary's been picked, we have 1 less person. And we have to multiply each one of those numbers together to figure out how many different ways we can elect the board of directors, which is 840. All right, this next one, you need to arrange 7 of your favorite books on a small shelf. How many different ways can you arrange the book, assuming that the order of the books makes a difference to you? This is getting to be easy, right, guys? Multiply. All right, let's move on to the next problem here. Actually, let's start talking about combination. Combination is a different arrangement of a group of items where the order does not matter. So let's think about a race again. Let's say we have 3 different winners from a race of 5 people. And it doesn't matter who comes in first, second, or third. If Miss S comes in first and Mr. R comes in second, Mr. K comes in third, that order is no different than if Mr. R came in first, Mr. K came in second, and Miss S came in third. So a combination is just an order where the order doesn't matter, the group of items where the order doesn't matter. As long as you have the same elements within the group, these 2 orderings make no difference. So let's look at an example of a combination, and we're going to look at what a combination is by first looking at a permutation. Part A says, how many different permutations are there of ABC taken 2 letters at a time? So we have 2 different letters that we're going to pick, and we want to figure out how many different ways we can choose these 2 letters from 3 different letters. So for the first position here, we could pick A, B, or C. That means we have 3 different options there. As soon as we picked A, B, or C for the second spot, we have only 2 different letters to choose from. So if we multiply how many different options we have a total of 6. 6 different options, 6 different permutations of ABC taken 2 letters at a time. A combination states that the ordering of those letters does not matter. So what that means here is if we're looking at AB and BA, these two are no different from each other. The order doesn't matter. So AB and BA are the same thing. Now we look at AC. AC and CA are the same thing. The ordering doesn't matter. So we're going to cross off that CA. BC and CB have the same letters. The order doesn't matter. So we've eliminated all the duplicates. And how many different combinations are there of ABC taken 2 letters at a time? We have a total of 3 different combinations of ABC taken 2 letters at a time. Now, how did we get the 3 mathematically? We figure out the permutation of ABC taken 2 letters at a time. So we have 3 times 2. But then we need to divide by the number of ways in which we can arrange 2 different letters, which represents A2 times A1. So we have 3 times 2 divided by 2 times 1, which gives us 6 over 2, which is 3. A combination is literally just a permutation divided by the number of ways the set can be arranged. Okay, so a 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors? So the first thing I ask myself, is this a combination or permutation question? The order doesn't matter on this one, so it is a combination question. Let me explain that. There are just 3 people on this committee, and it doesn't matter if you are first person on the committee, second person on the committee, or third person on the committee. The way that the committee members, the order of the committee members does not matter. So these 2 sets here mean the same thing. As long as you have Miss S, Mr. K, and Mr. R on that committee, then you're good. Let's figure out how to approach this problem. We want a 3-person committee, and there's 8 people. So the first thing we're going to do is find the permutation. We have the first spot can be picked 8 different ways. And the second spot then can be picked 7 ways. And then the third spot can be picked 6 different ways. If we multiply those together, then that gives us a permutation of 8 people taken 3 at a time. Well, what we want is a combination. So we need to divide by the number of ways in which we can arrange 3 people. So we need to divide by 3 times 2 times 1. And what that means is we can cross off the 6 on top and below. And that gives us 8 times 7, which is 56. So we can pick 3 different people on the committee out of a total of 8 in 56 different ways. Let's look at the next question. In poker, a person is dealt 5 cards from a standard 52 card deck. The order in which you are dealt the 5 cards does not matter. How many different 5-card poker hands are possible? So this is a combination question because the order in which you have those cards arranged does not matter. In the end, we just look at what the total of the cards means. So this is a combination question. It doesn't matter if we have that 10 first or that 10 last. We have the same hand no matter what. So we want to figure out a permutation of 52 cards taken 5 at a time, which means we have 52 times 51 times 50 times 49 times 48. And since we're looking at a combination, we need to divide by the number of ways in which we can arrange 5 cards, which represents 5 times 4 times 3 times 2 times 1. So I need to take out my handy dandy calculator to figure this one out. So we find that we can arrange these cards a total of 2,598,960 different ways. So there's a lot of different ways we can arrange 5 different cards taken from 52. All right, let's move on to we're going to talk about distinguishable permutations. We're going to count the number of different 9-letter words that can be formed by using the letters in each word. Don't worry about whether they're in the dictionary. So let's look at this first one here, dragonfly. How many different ways can we arrange that word dragonfly? Well, you have 9 different slots here. 9 different slots. And first thing we say is, how many different ways can we pick the first slot? Well, that's 9 different ways. How many different ways can we pick the second slot? Now we have a total of 8 ways. We work our way all the way down to 1. And so we multiply, we get a really big number there. Let's think about what it's going to be for butterfly here, okay? The thing about the butterfly is that we have 2 T's here. And the way that we arrange these 2 T's, if I have this first T here or this second T here, is no different than if I were to have the second T here and the first T here. So we can't double count the T's, okay? So what we need to do is divide by the number of ways in which we can arrange those 2 T's, which is represented by a 2 factorial, or 2 times 1. We haven't talked about factorials yet. We will talk about that. Divided by the number of ways which we can arrange the 2 T's, 2 times 1. And so this represents the number of ways which we can arrange butterfly. Of course, I'm not getting the final answer here, but hopefully you guys are getting the point. Let's look at this last one here. So we want to figure out the number of ways in which we can arrange the word bumblebee. Now we have some more repeats of letters. And we have the B that occurs 3 times. We have the E that occurs 3 times. Now, if we arrange the B1 here, B2 here, and B3 here, that's no different than if we were to arrange with the B3 here, and the B2 here, and the B1 here. That ordering makes no difference. So we need to divide by the number of ways in which we can arrange the B's, which is represented by 3 times 2 times 1. And we also have a repeat of the E as well. There's 3 E's there. So we need to divide by the number of ways in which we can arrange those 3 E's, which is represented by 3 times 2 times 1. So, how about this one? I'll actually figure out the answer for you guys. And so we can arrange that word bumblebee in 10,080 different ways. Let's move to some review problems. We're looking at a math department of 8 members is looking to assign 1 calculus teacher and 1 stats teacher. And how many ways can the department choose these positions? So we have a calculus teacher and we have a stats teacher. We have the ordering matter or not mattering? That's the big question here. Is this a permutation or a combination question? So if Mr. R has picked us the calculus teacher, first, and then Mr. K is then picked as the stats teacher. That order would be different than if we first picked Mr. K and then Mr. R. So is this a order mattering? Yes, the order matters in which we pick these teachers. So this is an example of a permutation question. The order actually matters. So we don't have to divide by the number of ways in which we can arrange the two teachers. We just have to think about the permutation. How many different ways can we first pick the calculus teacher? A total of 8 ways. How many different ways can we pick the stats teacher? A total of 7 ways. And so we multiply and we get a total of 56 different ways that we can pick the calculus and stats teacher out of a total of 8 different teachers. Let's move to the next example here. A math department of 8 members is looking for 2 co-chairs. How many ways can the department make their selection? Well, in this case, we're once again asking ourselves, is this a question where order matters or it doesn't matter? In this case, we're just looking for 2 co-chairs. So if I pick Mr. R first and then Mr. K second, does that ordering make a difference if we were to first pick Mr. K and then Mr. R? Does that matter? No, it doesn't matter. So this is a question where the order doesn't matter. We're looking for a combination. So the first thing we have to do is think about a permutation of 8 members taken 2 at a time, which means we're looking at 8 times 7 to start. But now we have to divide by the number of ways in which we can arrange those 2 teachers. So we have to divide by 2 times 1, which means we have a 56, divided by 2, which means we end up with 28 different ways that we can make our selection. Okay, let's look at the next question. We have Mr. Altamar is going to make a smoothie. So he lays out all his fruit options on the table: banana, apple, blueberry, strawberry, and orange. Mr. Altamar wants to taste each flavor, so he decides to only use 3 fruits. And how many different ways can he choose the fruits? So is this a permutation question? Is this a combination question? Does the order of the fruits make any difference? So if he is choosing his fruits, does it matter if he picks banana first, then apple, then strawberry? Or does it matter if he goes strawberry, apple, banana? No. In the end, it doesn't matter the order. He's going to blend them in the smoothie, and in the end, it doesn't matter the order that he picks those fruits. So this is a combination question. So first thing we need to do is take a permutation of 5 things taken 3 at a time. So we take 5 times 4 times 3, but then we have to divide by the number of ways in which we can arrange the 3 things. So we have to divide by 3 times 2 times 1. And let's go ahead and start crossing some things off here. I got a 4, which is 2 times 2, and the 3's here cross, the 2's here cross, and we're left with 5 times 2, which is 10. So he can choose those fruits a total of 10 different ways. He can choose a combination of 3 fruits taken from 5 in 10 different ways. Let's see if I have another example. Okay, so how many different ways can we arrange the word Anna? So there's 4 different slots, and we can pick the first slot in 4 different ways. We can pick the second in 3, the third in 2, and the last in just 1 way. But we need to divide by the number of ways which we can arrange the two n's here. Remember that the n1 here and the n2 here is no different than if we have the n2 here and the n1 here. So we need to divide by 2 factorial. But remember, we also have the a's we got to worry about. So we have to multiply by a 2 times a 1 here in the denominator. And so we end up with six different ways that we can arrange the word Anna. What about dude? 4 times 3 times 2 times 1 divided by the number of ways which we can arrange those the D's. So we have a 2 times a 1, and that gives us 12 different ways we can arrange the letters in the word dude. All right. We'll go ahead and stop here. Should we do this last one? Yes, we'll do this last one. How many different permutations are there of ABC taking 3 letters at a time? Well, that literally is found by taking the first spot goes with, you got 4 different letters that you could pick. In the second spot, you have a total of 3 that you could pick, and then you have a total of 2 that you could pick. So if you multiply these together, you got 24 different ways, which we see right here. The combination, we have to exclude some of these repeats, like ABC is the same as BAC according to a combination. So we have to divide by the number of ways which we can arrange the 3 letters, which means we have 4 different ways we can arrange